All right, we've talked about conditional statements and the different variations of the conditional statements to include converse, inverse, and contrapositive. And then we talked about the different elements of those statements. And we talked about the P and the Q. And if you haven't gotten to that point yet and haven't watched those videos, go ahead and watch those first before you watch this one. All right. So if the conditional and the converse statements are true, then those statements are said to be biconditional. Okay. So here's a little representation of what I got going on, right? So remember, this is the conditional statement format. If P, then Q. P is your hypothesis, Q is your conclusion. And if your converse, right, so this is the converse, okay? If Q, then P. If both of those are true, then these statements are biconditional. Here's an example. I have triangle ABC, okay? So if I say, if angle A plus angle B plus angle C, so this angle plus this angle plus this angle, right, equals 180 degrees. Another way to say this is if the sum of the interior angles of a triangle equal 180 degrees, because A, B, and C are the interior angles of this triangle. If they equal 180 degrees, I should make this blue. Let me make this blue. So if angle A plus angle B plus angle C equals 180 degrees, or I could also say if the sum of the interior angles of this triangle equals 180 degrees, then figure or object figure ABC is a triangle. Okay, that is true. All right, if I have a figure and the interior angles of that figure equal the sum of those interior angles equals 180 degrees, then the figure is a triangle. Okay, in every triangle, the sum of the interior angles is 180 degrees. All right, so now I'm going to write a biconditional statement for this, or a converse statement of this. If a figure or if we'll say if figure ABC is a triangle, then angle A plus angle B plus angle C equals 180 degrees. Okay, that's true too, right? So the conditional statement and the converse are true. Now let me give you an example of one that isn't true. A conditional statement that's not biconditional. Let me add one more thing to this, right? I could make this statement even better because it's biconditional if I use the if and only if statement, right? Because this is biconditional, I can now say angle A plus angle B plus angle C equals 180 degrees, right? Or the sum of the interior angles of a figure equal 180 degrees if and only if, okay, comma, we'll say the figure, that's fine, the figure ABC is a triangle. Right? So a biconditional statement allows you to use the if and only if statement. Right? That means that there's no other circumstance. That's the abbreviation for if and only is, IFF. Right? The only way that the interior angles of this figure would equal 180 degrees is if the figure was a triangle. That's the only way that that would work. Okay, so let me show you another example where this isn't true. So say for instance I have if a figure is a square, then it is, whoops, let me turn that to, I flop my colors. If a figure is a square, then the figure is a rectangle. Okay, so is that a true statement? Well, what is the definition of a rectangle? A rectangle is a quadrilateral that is made up of 4 right angles. 4 sides with 4 right angles. Right? So if I have a square with 4 right angles, okay, and all of these sides are the same length, okay, it satisfies the requirement for it to be a rectangle, because all you need for a rectangle is for these 4 angles of this quadrilateral to be a right angle. Okay, but if I go around, this is the if P then Q. If P then Q. Now what is the Q then P statement? I will go ahead and say if a figure is a rectangle, then the figure is a square. Okay, so there is a statement that is not true, right? I can have a rectangle made up of 2 different lengths of sides with 4 right angles, right? But it doesn't meet the requirements of a square, because these 2 line segments are the same, those 2 line segments are the same, but a square is when all 4 line segments must be the same and the angles are all right angles. So this is false, right? So I cannot write a if and only if statement for this one, right? If I say if a figure is a square, if and only if the figure is a rectangle. Okay, that's true. Well, it's not true, because it's not only if, right? Because I can have rectangles that aren't squares. Okay, so the if and only if statement would not be true. A figure is a square if and only if the figure is a rectangle. Well, that's not true at all, right? So that's why the biconditional statements allow you to use the if and only if statement. Okay, abbreviated as IFF. Okay, hopefully that makes some sense. And we're going to move on to some examples.